Hi, my name is Andrew Roberts, and this is my presentation on database hardening. To begin, we'll go over a little bit of overview about what a database is. It is essentially a centralized storage system for data. It uses tables, much like a spreadsheet in Excel, organized with columns and rows. These tables are often related, and they have names for each table. The reason databases exist is to have this large repository of data that is accessible from multiple sources by multiple different users and computers. There are several different models that have been designed to organize databases. First, the relational database is organized with a set of tables as well. And these tables can be rearranged to view information in many different ways, and based on how the information is related. Next is a network structure. This has a similarity to a network schema in which the database is categorized by a bunch of different nodes and how they are connected to each other. Next, there is a database that is organized based upon standard hierarchy, and this follows a tree structure of parents and their children underneath. The object-oriented database is structured because it stores data as objects, and this works well with many object-oriented programming languages. And an object relational database is simply a relational database that puts an object-oriented front end in front of it. There are many database management systems. For our purpose of this presentation, we'll be focusing on the Postgres database system. Postgres is an open source object relational database management system. It contains many modern features, such as complex SQL queries, SQL subselects, foreign keys, triggers, views, transactions, multi-version concurrency control, streaming replication, and hot standby. When moving on to hardening a database for security, as with many things, it is very important to maintain updates and routinely patch the database software. You also want to make sure that when you're setting up the database, that you only enable the services that are specifically required to run the database and have it accessible to the people that need access to the information that is held within. It's important to remove all default accounts and maintain strict authentication policies so that each user has their own specific user account with the privileges that are required for them. You want to keep a least privilege model so that they do not have access to anything they do not require access to. This is useful to make sure the data isn't taken by a user that does not have access to certain levels of data, and is also helpful for mitigating security breach. If an account were to be compromised, then that account is limited based upon the privileges that was designated to it. You want to ensure that there are no accounts and that all null passwords are disabled, and that there is a secure password policy in place that requires strong passwords for every user account. It is also useful, if possible, to purge a database of any historical information if the information is not required for day-to-day operation, and say it's records from 5 to 10 years ago. There's really no reason to keep those records stored on that database. They can be backed up and removed from the database so that information is no longer accessible unless you have access to that backup. And if this database is open to the internet, such as with web applications and other websites, you would probably want to consider a read-only replication of that database server. That way, the production database server is protected internally on a network, and the information is then replicated to a proxy server in a way that allows the database to have the information that is accessible to the internet. However, none of that data can be changed or written because the replicated database server is set as a read-only server. If there are specific applications and it's not meant to be open to the entire world, you would want to make sure that there is a whitelist policy in place, and that any computers that are allowed to access the server have been added to that whitelist, whereas every other computer would obviously be denied by default. This will maintain that the server is only accessible to the systems that are designated to reach the database. When considering security, encryption is always a valid option. It is recommended to both encrypt the traffic that is going in and out of the database so that all traffic is encrypted and maintained as secure communications between the client and the server. If it is possible to encrypt the entire hard drive that the database operates on, that is a good option. If not, maybe just setting the database itself to encrypt at the database level rather than having the entire operating system encrypted. Either way, it is recommended that the data within the database be encrypted and stored. When using encryption, it is very important to deploy secure procedures for maintaining these encryption keys, and that the procedures are well documented and enforced so that they are followed within the corporation. It is also important that the person that has the authority to decrypt this information is not held responsible to one single person. You need to have a redundancy in place so that if one person were to just up and leave, that all the data is not lost. These keys need to be stored securely, and if possible, at a secure offsite location so that they would have to be obtained, and if possible, maybe multiple locations with multiple copies of the key, so that if one were to be destroyed or if a site were compromised in particular, there would be multiple versions of that key available, and another version could be obtained, and that would allow the administrator to decrypt the information and hopefully re-encrypt it with a new key so that the compromised keys were no longer out in the wild. As for many security implementations, it is very important to audit the activity of accounts and systems that are accessing the database. When auditing is enabled, it should be set to log all logins to both the database software as well as the operating system. This will give traceability to which user accounts had access and when they accessed the system. This is also helpful for troubleshooting a compromised account. Any accounts that have access to restricted data need to be specifically set at a more robust auditing level to get information about every change and activity that they are involved in. There needs to be a knowledgeable team dedicated to reviewing these auditing logs and assessing how users are accessing the data, how often, and if there are any compromised user accounts that may be trying to make changes, or if there are any infiltration attempts. It is important that an audit policy would be set to instantly report any lockout scenario from, say, an account that is trying to be brute force attacked and they're trying to locate the password for that account. It's very important that an administrator know as soon as possible that this account is being targeted. That will allow the administrator to either disable the account or further audit the account to figure out where the attacks are originating from. If there is restricted data on the server, it is important to log every change that is made to restricted data. This data is set so that only certain people have access to it, and it needs to be known that when those people are accessing it and what changes they made, that those changes can be traceable. One of the most known vulnerabilities to a database is an SQL injection attack. A SQL injection attack allows an attacker to inject code specifically into a data field. This code may be malicious and either replicate or cause undesired effects inside the system. To protect against SQL injection attacks, it is very important that the SQL developers use very specific methods and statements within their programming so that these attacks can be mitigated. It is important to tell the developers that they need to use prepared statements as well as use stored procedures. If it's possible, to whitelist the input validation, that will help make sure that the people making changes are pre-approved. You also need to tell the developers to escape all user-supplied input, and any developers that have access to the system need to be enforced under a least privilege model so that every account is only able to access the data in which they were approved. At this point, I would like to thank you for listening to my presentation on database hardening, and I hope that you have a great day. Thank you.